Disaster recovery is about maintaining business continuation in the event of system failure. We have also known this as BCDR, business continuity and disaster recovery, which includes both backup and DR. But in this video, we are going to talk about DR, design for disaster recovery. It's about preparing the organization for any possible system failure and the ability to recover from it. DR planning includes multiple dimensions, which include hardware or software failure, while planning for DR always ensure you consider other operational failures as well, which include power outage, network outage, heating and cooling system failure, physical security breach, and different incidents such as fire, flood, or human error. Well, you must be wondering, I have included so many things, but aren't these supposed to be taken care by the cloud provider? Well, that's true, but these will definitely leads to a disaster. So you should have a plan handy. It's not like there would be a natural calamity. Only then you have to implement your DR or utilize your DR. But it could be anything which leads to the breakage of the system or system failure. So organizations invest effort and money in DR planning as per system criticality and impact, of course. Well, it is like you do have a mission critical application for you, because for people who are running application, they think with this perspective like every application is important. But when we think about DR, we need to find the business objective. We need to find how much cost is going in implementing DR, and how much business are we getting out of this application, and accordingly we build the DR, right? And there are various plans for the DR, and we'll dig into those plans in a bit. So uh, let me rephrase this again. A revenue generating application needs to be up all the time, as it has a significant impact on company image and profitability. Such an organization invest lots of effort in creating their infrastructure and training their employees for a DR situation. Well, people create a run book, step by step run book, so that because we don't know when the DR drill or actual DR is going to happen, so we should have everything documented as clear and crisp as possible, because whosoever is there who is actually implementing DR failover, he should be aware of every steps, right? And you never know who's there, so you should have all those things documented as clear as possible, and during the drill you practice that. So disaster recovery is like an insurance policy that you have to invest and maintain even when you are not going to utilize it. Well, we of course pay for that, but we don't want to utilize it, because if you are, then something big happened and nobody wants to face such a situation. It's bad. Anyways, well, as I was saying, there are various ways we can design the DR. These are like, it depends on the applications. It depends on the RPO and RTO of the application. It depends on the business. It depends on so many things. So let's go and talk about these options that we have to build the DR. We do have options like backup and restore, pilot light, warm standby, multi-site, active. They're like four ways. With the name you could understand, so let me write that down here quickly. Well, as shown now, I have write down everything. This is what we are planning, and these are the various options that we have here. Various ways we can design our DR strategy. So as you progress with each option, your RTO and RPO will reduce while the cost of implementation increases. You need to take the right trade-off between the RTO and RPO requirement and cost as per your application reliability. Well, we know. All right, let me give you this example. We have covered war, well architected framework, right? It composed of 5 pillars, and everything is a trade-off. It depends. Everything involves a lot of thinking, a lot of mind-boggling things. Like if you go with pillar one, then pillar two is gonna get impacted. Similarly, even in the DR, uh, it's a trade-off. Okay, and let me show you which with these options that we have. If we go from backup to this way, oh, I'm sorry, let me take this one. If we are going this way, right, if we're going this way, it is like from backup to pilot light to warm standby to multi-site active. It is RPU and RTO is getting reduced. I can write this down. RPU and RTO is reducing when you're going from backup and restore to pilot light to warm standby to multi-site. However, the price is getting increased or reduced in the opposite direction. We can say that, right? So let me write this down here. All right, I hope this makes sense now. And with the name, you can easily guess these different kinds of DR methodology or DR methods, and that's how it's impacting the cost and the RP and RTO. Now let's explore each one of these one by one to have a little bit more idea. So backup and restore. Backup and restore, as the name says, it's we are backing up our data and restoring in case of DR to a different region or a different location. So backup is the lowest cost option, but with higher RP and RTO, because everything is manual. You need to move your data, you need to restore your data, then you need to configure everything. This method is simply to get started and extremely cost effective, as you need just backup. And it could be anything. It could be, if it's on premises, it could be your tape drive, or you could utilize the cloud storage as well, like storage account, right? So that's backup and restore. But we do have Pilot Light now. In Pilot Light, we need to think of, before Pilot Light, I should definitely talk about this backup and restore recovery, disaster recovery method is easy to set up. We just need to set up the backup and make sure it is redundant to that particular location. If we talk about Azure, so it should be geo redundant if we talk about region, or zone redundant if we talk about a particular location or data center. So it's inexpensive, and you do not need much effort to establish this kind of DR method. However, in this scenario, both RPO and RTO will be very high. RTO will be downtime until system gets restored from backup and start functioning, while RPO will have an amount of data loss which depends upon the backup frequency. So let's quickly check the Pilot Light. I hope backup and restore is clear now. So Pilot Light is the next lowest cost DR method after backup and restore. And as the name suggests, you need to keep the minimum amount of core services up and running in a different region. Of course, you can spin up additional resources quickly in the event of disaster. So you would probably actively replicating the database tier, then spin up instances from a VM image or your VM in that infrastructure. So it is more like in one region. If I could draw something here for you, let's suppose this is region 1, Let me call it region 1, and this is region 2. Okay, so what we are doing, we are only replicating something, not everything. Everything is not up and running in the region 2, but something. All right, so now you have seen, let's suppose this is your web server and this is your app server in region 1, and this is a DB. So in case of Pilot Light, we are only replicating DB to a next region and not creating anything else. Not Don't want to spend too much money on the infrastructure. But in case something happens, then and there we'll definitely go ahead and deploy the other resources which are needed for the functionality of the application, right? So that would be like Pilot Light. You could use infrastructure as code, so to lessen the RTO, and that's the practice nowadays, utilizing codes. And Pilot Light scenario is pretty much similar to backup and restore, where you take the backup of most of the components and store them passively. However, you maintain active instances with a lower capacity for critical components such as database or authentication server like Active Directory, which can take a significant time to come up. And that should be in sync so that it knows what exactly is the status. So that is one of the another region that we should have those replicated as in sync as possible. You need to be prepared to start all required resources automatically, which include network settings, load balancers, and virtual machine images as required. As core pieces are already running, recovery time is faster than the backup and restore method. And this Pilot Light is very cost effective because lots of infrastructure is not running. Only the one which is needed, absolutely needed, is running, like DB and AD. You need to enable the replication of all critical data to the DR site, which is must. All right, so for Pilot Light method, or you need to make sure the frequency of the backups that define the RPO, and RTO will definitely is higher as compared to warm standby, but lower as compared to the backup and restore. So let's quickly check the next that we have in our uh, DR design is a warm standby. Warm standby, also known as fully working low capacity standby, is like the next level of the Pilot Light. It is the option where you use the agility of the cloud to provide the low cost DR. It increases the cost, but also allows data to recover more quickly by having a small subset of services already running. You can decide whether your DR environment should be enough to accommodate some percent of production traffic, like 30 or 50, not all, but some uh, traffic. Alternatively, you can also use this for non-production testing as well. So you have another use case for this kind of DR, and it's certainly very helpful when we implement DevOps, like a CI/CD for blue-green deployment, right? So when it comes to a DB, warm standby has a similar approach to Pilot Light, where data is continuously replicating from the main site to the DR site or AD. However, in warm standby, you are running all necessary components 24/7. However, they do not scale up for production traffic. So that is the only difference. In Pilot Light, we were not running any other component except the AD or DB, which is supposed to be in sync, which should be in sync. But in warm standby, it is an active environment. It's a running environment. The capacity is not like the primary environment. Okay. All right. So if we see, the warm standby DR pattern is relatively complex to set up and expensive. The RTO is much quicker than Pilot Light for critical workload. However, for non-critical workload, it depends upon how quickly you can scale up system. While the RPO depends upon the replication type. All right. So if you see this example right here, now everything is already set up, right? But the skew size is smaller as compared to the primary region here. If we take this example, now let's explore the multi-site active, which is the best way or the lowest RPO RTO. This multi-site strategy, also known as hot standby, helps you to achieve near zero RTO and RPO. In multi-site, your DR site is an exact replica of the primary site with continuous data replication and traffic flow. It is known as multi-site architecture due to the automated load balancing of traffic across regions or between on-premises and the cloud. With the help of Traffic Manager or Front Door, they have various kinds of options that you can utilize for traffic flow. The advantage of this multi-site approach is that it is ready to take a full production load at any moment. It's similar to warm standby, but running full capacity in the DR site. If the primary goes down, all traffic can be immediately failed over to the DR recovery site. And of course, multi-site pattern is most expensive because almost same amount of infrastructure with the same SKUs are running on the secondary site. However, in this scenario, the RTO objective is much quicker for all workloads, and RPO, of course, depends upon the frequency of your backups. All right, well, in this video, we just talked about the various disaster recovery pattern and methods and how it impacts the cost, pricing, RP and RTO. In next video, we'll explore it a little more. Well, thank you for watching.